So now we are going to see about energy stored in the capacitor. So capacitor is a charge storage device. It does not store only charge, but also it stores electrostatic potential energy. இப்போ the capacitor வந்துட்டு எப்படி நம்ம சார்ஜ் நம்ம வந்துட்டு கொடுக்குறோம் அப்படின்னா with the help of the battery. பேட்டரியிலேருந்து என்ன போகுது, ஒரு சைட் ஆஃப் கெப்பாசிட்டர் இருக்கக்கூடிய எலக்ட்ரான்ஸ் dq அப்படின்ற ஒரு எலக்ட்ரான்ஸ், ஒரு ஸ்மால் எலக்ட்ரான்ஸ் அப்படி என்ன பண்ணுது, which is going through the other plate. So the electron is transferred within the two plates only. It is not coming from the battery. இப்போ ஒரு பிளேட் இருக்கக்கூடிய எலக்ட்ரான்ஸ் அப்படியே என்ன ஆகுது, பாசிட்டிவ் பிளேட்ல இருக்கிற போயிட்டு அந்த சார்ஜ் வந்து ஸ்டோர் ஆகுது. அப்போ ஸ்மால் ஒர்க் டன் நம்ம அங்கே கொடுக்குறோம். அது எவ்வளோ ஒர்க் டன் கொடுக்குறோம் அப்படின்னா dW is equal to V dq. Here V is the potential difference, which is a constant term. அப்போ இந்த dW small amount of work done, the small charge, இந்த small charge நான் ஒரு பிளேட்ல நான் போயிட்டு ஸ்டோர் பண்ண அப்படின்னா ஸ்மால் அமௌண்ட் ஆஃப் ஒர்க் டன் நான் பண்ணணும். ஸோ அதான் இது. Already we know C is equal to Q by V. So V can be written as Q by C we can write. So substituting here, so dW is equal to V dq. That is, we can write this one Q by C. So Q by C. So this is a small work done. So I'm going to find the large work done. This is infinitely very small charge. The total work done to store a charge is W. So now we are going to integrate W, that is the work done. It is integration of 0 to Q by C dq. So this is a limit 0 to Q from the charge lower value. So 0 charge to that maximum charge we stored in the capacitor. So 1 by C is a constant term taken from outside. So W is equal to 1 by C integration of 0 to Q dq. So we can integrate this one by integration you know. So when we are integrating that x, which means dq. So here it is 1 q dq. So we integration you know, that is integration is x, if you integrating x means with respect to x means x square by 2. If you integrating x square with respect to x means x cube by 3. So we are now going to integrating that charge w, charge q. So w is equal to 1 by c integrating q, and write that q square by 2. The limit is 0 to q. For the limit we should apply the limit, upper limit minus lower limit. So 1 by c, upper limit is q square by 2, the lower limit is 0 square by 2. So we can write w is equal to q square by 2c. So this much of work done is done by the battery to store the charges. So that charges stored in the form of electrostatic energy in the capacitor. So the same charge work done is converted into that electrostatic energy. So it is equal to q square by 2c. So we know the other equations. Q can be written as q is equal to cv. So substitute here, electrostatic energy V is equal to q square means c square v square by 2c. It cancelled. So electrostatic energy stored in the capacitor is 1 by 2 cv square. Hence electrostatic energy is directly proportional to capacitance of the capacitor, and electrostatic energy is directly proportional to the square of the potential difference. And in we find that electrostatic energy. We have to find that where the electrostatic energy stored. And the electrostatic energy எங்க ஸ்டோர் ஆயிருக்கும் அந்த பேட் அந்த கெப்பாசிட்டர்ல அப்படின்றத இப்போ நம்ம டிஸ்கஸ் பண்ணிடலாம். We know the familiar equation C is equal to epsilon naught A by D, capacitance of the parallel plate capacitor. So on the derivation we பார்த்திருக்கோம். V is equal to ED, potential gradient equations ல வருது. Substituting here, so E electrostatic energy is equal to 1 by 2. What is C value? Epsilon naught A by D into V square means you can write this E square D square. So this D and this term get cancelled. Electrostatic energy U is equal to 1 by 2 epsilon naught AD E square. Area into D means thickness, which means the distance between the two parallel plates. அது ரெண்டுக்கு கூட இந்த thickness, small distance, and the thickness என்னது இந்த D. So area into thickness, we can write that volume. So volume can be written as area into that D. So we can write, instead of this AD we can write V. So U electrostatic energy is equal to 1 by 2 epsilon naught V E square. So now we are going to find the energy density. What is energy density? The energy density is defined as the energy per unit volume of the space. Energy density is the energy per unit volume. So the energy, electrostatic energy we find per unit volume. So small ue is equal to 1 by 2 epsilon naught V E square whole divided by V. So this V get cancelled. So the density, electrostatic density U is equal to 1 by 2 epsilon naught E square. So the density which is directly proportional to that square of the electric field, which means which is entirely depends on the electric field alone, and this much of energy is stored here due to this electric field. From this we can say the energy density, it is not depends on the size of the capacitor, because here it is area is not come, which means the density which that is electrostatic density is not depends on the size, but it is depends upon the electric field intensity E square. So this equation is applicable any type of capacitor charge configuration. Any type of charge configuration, this equation is applicable. Thank you.